So here we have, we're going to look at the number of solutions for a system. And so some key ideas here, I'll have my highlighter on standby here. A system of linear equations can have one solution, right? So there it is. You can have one solution, no solution, or an infinite number of solutions, right? Before solving, you can predict, right? Before solving, you can predict the number of solutions for a linear system by comparing the slopes and the y-intercepts of the equations, okay? Right, so you'd be comparing the slopes and the y-intercepts. I would say for the most part, 99.9% of the time, you just have to worry about the slope, not necessarily the y-intercept. There's only one instance where you need to worry about the y-intercept. And so here you have the graphic way. So if you were to look at the graphs of both equations, right, there you have, right, intersecting lines. If lines are intersecting, which for us was the case up until now, you would have one solution, right? And this is the POI, that is the solution, right? You have one solution, and that is what we're referring to as the point of intersection, okay? And what is true about these two equations? They will have different slopes, right? Y-intercepts can be the same or different, right? So the key here is they have different slopes, okay? And when you go to the lines that are parallel, right? Remember from chapter 6, if lines have the same slope, they are parallel. They run alongside each other, right? So you would have no point of intersection, right? So I'll just make a note of that, right? No POI, right? Never meet, never cross each other. Okay, there will never be a point where they cross each other. So there, if you have the same slope and a different y-intercept, okay, then this line is to have this system that will not have a solution. There is no solution to the system, okay? So there you have the two most common ones are either there is a solution or there's no solution, right? And if you have to compare between one solution and no solutions, all you have to look for is the slope, right? You just have to make sure they have a different slope. If you were to create a line that has a different slope than the first equation, then they will have an intersection. But as soon as they have the same slope, they will never meet. It doesn't matter what the y-intercept is, okay? So in a sense, they have to have a different, these two lines though, they have to have a different y-intercept, because if they had the same y-intercept, right, then they would have a point where they have in common. So you can't, between these two lines, okay, if you're graphing both lines, you have to also make sure they have a different y-intercept. So I was kind of contradicting a little bit. I don't know if you're like, wait, just look at the slope. So they have to have different y-intercepts as well. So these are the two conditions for lines to have no solution, okay? Coincident lines, an infinite number of solutions, right? And I will just make a note here on the side that the lines coincide, right? When you're coinciding, you're basically saying the same thing, right? So it's basically two lines, both equations. Let's write this. Both equations are or represent, sorry, not are. Go back here. Represent the same line. Okay, so you basically have one line, the equation of one line, and then you might have the equation of a second line, and that second line may look different at first, but when you rewrite it to slope-intercept form, you will realize, because the slope-intercept, when you rewrite, it could be in general or slope point. If you rewrite those equations into slope-intercept, they will look exactly the same. And if that's the case, you're talking about the exact same line. So basically, you have two lines, one on top of the other. Before we continue, I will do this, okay? You'll see Desmos on your screen. So I'll just pause I'll just keep the recording. It won't be on there, but so let's do a little bit of investigating, right? So let's stick with the slope-intercept form. So if you go y is equal to, let's say we go 2x plus 4, let's say, right? 2x plus 4. If you create, let's create a system. So let's create a line that has the same slope. So we're going to go 2x again. But in this case, you have to make sure that your y-intercept is different. So because if you go plus 4, now you're looking at the same line again. So you have to make sure the y-intercept is different, even by a little bit. See how my second line here they have both the same slope, but they have different y-intercepts. And so in this case, you've created a line that will run alongside the other. If you have the same slope, you are both rising and running the same amount every single time, right? So from one point to the other, you're changing at the same rate. So you will never meet, right? There's no way you're going to meet. So let's introduce another line. So for example, let's clear this one here, the blue one. Let's say you're given this equation here, and you're asked to come up with another equation that would actually have one solution. How would you do that? Well, the first step is to make sure that your slope is different. So let's say instead of 2x, we're going to say 3x. Right? 3x like that. And you could actually leave it like that. You wouldn't have to change anything. If you were to add the same y-intercept, that would actually cross, because they share the same y-intercept, they would cross at 0, 4, right? If you make your y-intercept -5, for example, you can tell they're not touching right now, but you can tell that they're getting closer every time. So if I zoom out, there's that point of intersection that I wanted, which is 922. It's way off the grid, but it is there. You can tell that they're going to meet at some point. Okay, so how did we create one? We just made sure the slopes were different, and then you know for sure that they are going to meet. Okay, and the y-intercepts, it doesn't matter if they're the same or different, as long as the slope is different. Okay, and then let's see what happens. I'm gonna follow me, please. I'm gonna do it together with you. I'm gonna rewrite the top equation here into the general form. So you're just gonna have to help in your mind bring the 2x over, subtracting, sorry, the 2x up here is coming over the equal sign on this side. So then it's plus 9. Sorry, not plus 9, plus y, because the y is already there, and the 4 will come over subtracting as well, equals to 0. Notice what just happened, right? It's still the same equation. So I can turn off the red one for now. I can actually get rid of it. So we're now looking at the general form of the equation, right? Notice that when you have the general form, it's harder to see the slope and the y-intercept. There's a way to do it, but it's harder. I would recommend rewriting to slope-intercept. It's a good skill to keep, and it doesn't take that long anyways. But let's say, for instance, this is, if you can pay attention to this, if I asked you, let's start with negative 2x plus y minus 4 is equal to 0. If you notice that a second equation right underneath it has been created by multiplying the first equation by a constant factor. So let's multiply the first equation by 3. If you multiply the first equation by 3, right, you would get negative 6x plus 3y negative 12 is equal to 0, because 3 times 0 is still 0. Notice that you have now basically you're still talking about the same line because you have multiplied everything by the same constant. So that's something to be aware of. If you notice that there's a way to get from the first one to the second one by just multiplying it by the same constant. Because remember when we did elimination or substitution, when we multiplied the whole equation by the same number, we would write the new one right next to it. We're still talking about the same equation. The equation itself has not changed. So really here, we're also talking about two equations that refer and point to the exact same line. Okay, so be aware of that. Sometimes you won't see it. You will just go ahead and rewrite both of them into slope-intercept, and that's fine. But if you see this, you can already kind of predict what's going to happen. Okay, so there's your Desmos lab here, just to give you a bit of a visual as to what it is that we're going to do. All right, let's keep going here. I'm just going to read a little bit here before I move on. For some linear systems, reducing the equations to the lowest terms and comparing the coefficients of the x terms, y terms, and constants may help you predict the number of solutions, right? So that's what I just talked about. If you were to divide the whole thing by 3 or something, if possible, if you reduce it a little bit, you might be able to predict a little quicker. But here's the fail-safe method of doing it, and I'm going to show you how to do that in a bit, okay? Consider the system of linear equations 3x minus y minus 4 is equal to 0, and 6x minus 2y is equal to negative 9. If you were to take, and here you have to use your imagination a little bit, right? If you were to take this as our first equation, and this here is our second equation. So I give you both of them and they look slightly different. This is in general form because it's equal to 0. This one is technically in standard form, so it's not in general form because you don't have the equal to 0 just yet. But that doesn't matter, right? If you rewrite, okay, rewrite into slope-intercept, okay, this always works. Okay. If you rewrite in slope-intercept, so you want it in this format, right? mx plus b, like this. Notice that both lines have a slope of 3. Okay. So as soon as as soon as you notice that both lines have a slope of 3, both have a slope of 3, you're either in the category of them being parallel and two different lines that just are parallel to each other, or coinciding lines. Okay. Since they have different y-intercepts, right? Different y-intercepts, lines are parallel. Parallel lines have no intersection, so this system has no solution. Okay. Graphing the equations together, right, shows that the lines are parallel and will not generate any solutions. This graph, I wish I could have made it with you from scratch, but notice that if you have them rewritten like this, so watch here over where I'm hovering, 3x minus 4, I start at -4 and I use a slope of 3 over 1. So -4 is here. I go 1, 2, 3 over 1, 1, 2, 3 over 1. Okay, so this is the equation, the slope, or the equation 3x minus 4. Okay, so the labeling wasn't there. And this equation here, if you look at it, 3x plus 9 over 2, that's 4.5, right? So you start at 4.5 here, and since we're running out of runway, you just go down 3, so 1, 2, 3, and back 1, right? So this is the line, y is equal to 3x plus 4.5. Oh, sorry, 9 over 2. We want it as a reduced fraction, remember that. Okay. So lines never meet. Lines will never meet. Therefore, no solutions. No solution in this case. So graphically, you can just describe, hey, lines will never meet. You can tell, no solution, right? But if you just look at the equations, right? Same slope, different y-intercepts. We're talking about two separate lines because they have different y-intercepts and they have the same slope, so they will never meet. Okay. So there's your walkthrough to that one. Okay. I'm just gonna go ahead and go through one more step here. This is another way that you could show that lines never meet. So let's pretend here. Let's take these here and let's use elimination. By elimination. Let's solve this. We're gonna try to solve this by elimination and see what happens. Just note, we already know that there is no solution, but we're gonna take a step back and say, hey, what would have happened if you tried to do this by elimination? So we take the first one, 3x minus y is equal to, let's bring the -4 over to the other side so that it looks like the way the equations have been presented to us so far. And then we'll take that second equation, 6x minus 2y is equal to -9. Okay. Right now you can't cancel out anything as is. So what I'm going to do is I'm going to multiply the top one by -2, because then I'll have both 6's, and that will fix the problem for me. So I'm going to go times -2, that gives me -6 plus 2y is equal to -8. Okay, and then this one I'm just going to copy it, so no need to multiply it by anything. So I'll just go 6x minus 2y is equal to -9. If you were to now add these two up, right? If you add both equations, you get 0x plus 0y is equal to -17. So 0 is equal to negative 17, which is not true, right? This shows that the system has no solutions. Because this cannot be. 0 is not equal to negative 17. So that's another way of, and if you were to use, oh, shouldn't it be, I'm using, Alexander, I'm using these two, the original ones up here. I'm not using the rewritten form, right? Because I'm using the ones up here, not these ones, even though you could have, but I just used the ones up top here. Yeah, good observation. Okay. All right. Okay. Let's just, before we go to the next page, let's just do this one more time. If both equations you recognize they have different slopes, boom, done. There is one solution, right? You don't need to worry about the y-intercept. If the slope is different, it will have one solution. Got that point? All right. If they have the same slope and then different y-intercepts, right? Then you're talking about two different lines that will never meet. So the emphasis on the different y-intercepts. But if you have the same slope and the same y-intercept, we are really talking about the same line. Both equations are actually talking about the same line. So because one is stacked over the other, we have an infinite number of solutions, right? So because the one line is over the other, and it's just like they're touching in every single point. They are coinciding, okay? So there's an infinite number of solutions, okay? So keep that in mind, and then that's how we're gonna have this in our minds the whole time as we go along. Okay, so let's now do a little bit of investigating and seeing how we can either create. You might be asked to create. It's like, hey, here's an equation. Create a system now that would have one solution, or create a system that would have no solutions, right? Create a system that would have an infinite number of solutions. So we're going to kind of go back to this to help us do that, okay? Because if we know this, we can actually make it happen, okay? Okay. So here is just straight up determine the number of solutions for each system, okay? So I will rewrite this. Method one, where am I going to do that? I'm going to run out of room there. I'm going to do it here. Method one, rewrite both equations into y equals mx plus b. And that's going to be the first method that I'm going to show you here. That's the fail-safe, always works. So I have one here and I have two there. I'm going to label them to distinguish. So the first one, I will start with y is equal to, the 2x comes over subtracting, so it's negative 2x, and the 8 is already on the right side, so we just keep the sign that it has. right? So there's that. And for the second one, I will just say 2y is equal to, the 2y stays on the left side, keep the sign, it happens to be positive. 4x will come over subtracting. That term comes over subtracting. The 16 is already there. Okay. Now we still want to isolate y, so we divide everything by 2. So y is equal to negative 2x plus 8. Okay. So now here's my conclusion. Same slope, same y-intercept. Right? They have the same slope, same y-intercept. Therefore, lines coincide and there are an infinite number of solutions. Infinite number of solutions. Okay, so I will highlight the slopes and I will highlight the y-intercepts. Okay, so we're really talking about the same line. So it's almost like you're graphing the same line again. And so therefore it's an infinite number of solutions because they're touching in every single point. Okay, so that's that. I will talk about the second method here. Notice that 2, right, that the second equation here is double the first one. Therefore, lines coincide, infinite number of solutions. If you notice that, you can also just right away conclude, but be careful with that. Because sometimes even if the sign is different, it's not going to be, because it has to be, you have to be able to multiply the first by the same constant and get and make sure every single number on the second equation matches, right? You actually get that product. Because if I had a negative 16 here, right, you multiply everything by 2, 8 times 2 is not negative 16, so right away it would change the scenario. So I would say this is the fail-proof method, right? If you do it right, you will be able to see right away whether or not that is the case. Okay. Okay, so let's rewrite here. So we'll call this first one and the second one. So for the first one, I just get y is equal to negative 3x plus 9. Okay, the 3x comes over, subtracting, the 9 is already there. We're done. That's isolated. So it doesn't take very long, does it? 6x plus 2y is equal to 12. We will keep the 2y there. The 6x comes over, and there's a 12 already there. Divide everything by 2. Watch your signs. Watch signs, please, okay? If 2 had been negative, right? If it had been 6x minus 2y, then you would have had to make sure you divide both sides by negative 2. That never goes away, okay? That always stays the same. Okay, y is equal to negative 3 over 2x plus 6. Okay? All right, so watch what I'm going to do here. I'm just going to focus. Oh, somebody said something here. Oh, yeah, hold on. Shouldn't it be? It's -3, not, it's -6, not -3. Oh, yes. Sorry. Thank you. Everybody, did you see that? Did you hear that? Yes, I somehow missed it. So the 6x, which is here, comes over -6x. That's right. So that gives you -3, -3x plus 6. There we go. That's right. Thank you. I want to say something here. When this happens to you, you better be consistent with your answer, right? So yes, you will lose marks for making a mistake here, but if your answer is still consistent, you'll still get marks there. So in this case, okay, slopes are different. Sorry, slopes are the same slope. Okay, same slope, but you have different y-intercepts. Therefore, lines are parallel. You can just use this symbol from now on. Right? Lines are parallel, no solution. That's it. So you have to say what would these lines, what would happen if you were to graph these two lines, and then conclude no solution, right? So no solution, and then we had infinite number of solutions up there. Okay. I will block this off like this, folks, so that it's okay. So there's that breaks that up, and then this here breaks, because that's why I made a mistake. I was looking at the wrong equation. So again, I will highlight just that I'm looking, what am I looking for, right? I'm looking at the slopes and I'm looking at the y-intercepts. And there you have it. So if both are the same, infinite number of solutions because it's coinciding lines. If the slopes are the same but the intercepts are different, two different lines that are parallel because they have the same slope. Okay. And then our last one here, we're still going to call this 1 and 2 like this. So for the first one, it's y equals 2, the x comes over subtracting, and the 8 just tags along like that. And for the second one, I have y is equal to the negative, it's -5x. When it comes over positive, like so. Okay. And you're done. Right away, you can tell that the slopes are different, right? Different slopes. Don't worry about the y-intercept, right? The slopes are different, therefore, one solution. Lines will intersect because lines will intersect. And in this case, I'll just highlight the negative in front of x and the 5 there. That's all I'm going to do, because you don't even need to look at the y-intercept. If the slopes are different, you're done. Okay? No need to go any further. I mean, rewrite it and then look at it, right? But you don't need to talk about the y-intercept. Before I move on, these were all nice and easy, no fractions, nothing like that, okay? If there are any fractions, if you have denominators in any of them, still do what we've always been doing. We try to eliminate them. So multiply the whole equation by the lowest common multiple so that they cancel out, or that they reduce, so that you only have whole numbers, okay? Because if you don't, it's going to get really complicated, the rewriting process, right? So that still stays the same. We're now just focusing on what do we look for to make this decision as to whether or not you have infinite, no solution, or one solution, right? So how about we do, I don't know if you want underline, but I'm going to circle infinite, no solution, and one solution. I want that to stick out, so you have all three examples right there for you to look at. Okay. Example 2. Given the equation negative 2x plus y is equal to 4, write another linear equation that will form a linear system with exactly one solution, no solution, and infinite number of solutions. So we're going to create 3 different systems, but this is going to be our first equation in the system. And here I'm going to apply a little trick. I'm going to rewrite it already. Okay? So rewrite before I even start. This gives you y is equal to, the 2x comes over. Sorry. Because it's easier when your goal is to create another equation, it's better to have it in the slope intercept form. So the 2x comes over adding, and the 4 is already there. So this is going to be my first equation for every single system. So let's start here. Y is equal to 2x plus 4. We're going to do the same thing here. Y is equal to 2x plus 4. And y is equal to 2x plus 4. So imagine these are 3 different questions, but the first equation we know is going to be the one we're given. Okay. And so now, here we go. We're going to create a second equation. You create it. Okay, it's up to you. So on a test, technically I should be seeing different equations across the board when this is the case. And so basically, what you want to do to create the second one is, all you want to make sure of is that the slope is not equal to 2. Right? You want to make sure that the slopes are different. That is the only goal. If that is the case, then they're gonna meet, and there's gonna be one solution. It may not be a perfect round number solution. It could be a decimal, right, fraction. We don't know that, but we're just gonna say, hey, I'm just gonna change it to 3x plus 4. That's one option. Or if you're a little bit more extravagant and you wanna show off, right? You can go negative 3 over 2x plus 9, right? Or y is equal to Let's do the a line that would be perpendicular. Do you remember that? Perpendicular, scratch, scratch, right? Negative reciprocal of this. So I'm always looking back to the original, right? A negative reciprocal would be negative 1 over 2x. And we can go plus 7 over 3, right? It doesn't matter. So right, or dot dot dot, right? Like the list is endless, right? As many, you can come up with any equation that that has a different slope. Okay, so let's highlight. Let's write slope, slope, right? That's all we were looking at. So this is equation 1, and this would be your second equation, right? So you have options here. Which one you would have picked, that's up to you. Keep in mind that the question may ask you to write it in general form. If it's asking you to write it in general form, I would not come up with very extravagant slopes. I would just keep it simple, because if you have a fraction, you got to get rid of it, right? Because remember, general does not have fractions, and a has to be positive. Okay. And then you want no solution. So same slope, different b, right? That's how you're going to create your no solution system. So we're going to go y is equal to same slope. So you can't, there you have no choice to use the same slope, but we're going to go minus 4. How's that? That is a different slope, right? A different y-intercept, my bad. And so we're going to keep that like that. What am I going to add here? Rewrite to general form. I will just make sure a is positive and no fractions. Okay. Rewrite to general form. That means that a is positive and that there are no fractions in it. Okay, so this one, the top one here, we would go negative 2x, because the 2x is here, it comes over, plus y minus 4 is equal to 0. I'm going to multiply this whole thing by negative 1. Right, so arrow goes here, and then arrow goes here. So that would give me 2x. Negative 1 times y is negative y, plus 4 is equal to 0. And then we'll do the same thing with this one. We get negative 2x plus y plus 4, right? Because the negative 4 comes over adding, is equal to 0. We multiply by negative 1 again. You could divide by negative 1. 2x minus y minus 4 is equal to 0. So this is a system, and this is my system. Like these are system in general form. Just in case, right, I asked that in general form, system in slope intercept. Right, this is a system and slope intercept. This is the system in general form. All right. right? Infinite number of solutions. We want same M, same B. Okay, so we're just gonna do this 2x. Um, we're gonna create a copy. We're gonna make it a little bit because usually they're not gonna look exactly the same on a question. So I would like you to do the same. We're just gonna take this and multiply it by 3, let's say. So it's 3y is equal to 6x plus 12. Right? If you do that, then you'll be fine as well. So basically we'll say multiply the first, so this is our first equation here, and this is our second, right? Multiply the first by a non-zero integer. That's how you would get that. And then of course I could ask you to write that in general form and so forth, right? All right, determine by inspection. Okay, by inspection, the number of solutions each linear system has. Okay, and so basically, whenever you see a pattern, if you're ever going to see a pattern, there will be infinite number of solutions, guaranteed, right? And so whenever you see that the first one has been, you have multiplied the first one by a constant term to get the second one, you know that there's going to be an infinite number of solutions right away, because that's basically what happened here. That's how we got our second equation. But in this case, you don't see that. It's like times 1, but this is different, right? So you already are suspecting that this may have no solutions or one, we'll see, right? So just rewrite the first and the second one. So the first one, we go 3y is equal to negative 2x plus 12. Divide everything by 3. Y is equal to negative 2/3 x plus 4. And the second one, we have 3y is equal to, the 2x comes over, plus 16. Divide everything by 3. That's negative 2/3 x plus 16 over 3. We'll leave it like that. Same slope. Always make reference to the slope, different y-intercept. Therefore, no solution. Lines are parallel. You have to make sure you understand that they're all connected, right? That having the same slope but different y-intercept is talking about two different lines that run alongside each other. Lines are parallel, they never intersect. Therefore, lines are parallel. Okay? So this is our first equation, second equation. Here I'm just going to conclude line 2 is double line 1. Lines coincide. So system has an infinite number of solutions. right? Basically, if you take the first one and you multiply it by 2 or -2, or right, like if you see that it has been multiplied by the same constant to get the second one, or divided for that matter, right? It doesn't matter. But if you go 2 times 2 is 4, right? 2 times 3 is 6, 2 times 12 is 24. Sign and all, right? Everything is consistent. No solution. And even if you were to rewrite it, it's still okay. If you always stick to this method here, you're still okay. Do that. Okay, this is it for today. Let me just give you the homework questions to try. I'll just look it up 1 second.